Hi everybody, this video is going to work on finding missing sides and scale factor when you are working with similar figures. So I want to start by just making the statement that we know these figures are similar. So we're not trying to determine whether they're similar or not. We are naming what the scale factor is and finding missing sides, and we're even going to solve for x as well. So let's jump right in. Example number 1. So I'm going to just make a shape here. I don't know, that looks good enough. And then we'll make one that is slightly larger just to show. And, whoops, well, let's just pretend that looks good. Let's say this side is 21, this side is 24, let's say this one is 40, this one is 35, and this one is 35, just for fun. All right, so first thing that we want to do is establish which one is the new shape and which one is the original shape. And for our purposes in this video, I'm just going to say that the shaded shape is the original shape. So let's say this one is the original. So we're just going to go with the shaded is the one that is the original. And if I had named them, we would look at for the A and the A prime and B prime, that kind of thing. So we'll say this is the original shape, this is the new shape. So when we're finding scale factor, it's so simple. If you can remember this one, I don't know, I guess rule, scale factor always, always, always can be found by putting the new over original. So if you're on a graph with ordered pairs, you can do new over original. If you have shapes like this where you just have side lengths, you can do new over original. It doesn't matter, it works for everything. So what we need to do is just make or match our corresponding sides. So I drew these to look like they were similar as well. So I can see that 21 and 35 match up with each other. So if this is the original shape, this is our new one. So the new shape side length is 35. The original side length that corresponds with it is 21. I can reduce both of those by 7, which makes 5 over 3. All right, I'm just going to show you that it works regardless of which sides you choose, as long as you're picking corresponding sides. So if we were to look at these two sides, again, this is the original shape, this is the new shape. So if I set this one up, the new shape side is 40, the original shape side that corresponds is 24. I can reduce both of those by 8, which would give me 5 over 3. So I think I can confidently say now that the scale factor is 5 over 3. So let me tell you what that does for you. If you work the other direction, if we take the original shape and multiply by the scale factor, we will get the new shape. Okay, so, and if you look at this right here, this is really just an equation. So if we multiply both sides by the original, then the new shape is going to be the scale factor multiplied with the original side. So that would just be rearranging this equation. So just to show you what I'm saying is, if we took the scale factor, which is 5/3, and multiply that by one of the sides of the original shape, so I'll just do 24. So if we multiply that by 24, I like to cancel, so I'm going to reduce that right there, and I get that the new side should be 40. So that's one way to look or double check that your scale factor is correct. So again, this one, scale factor is 5/3. All right, for our next example, we're going to find a missing side this time. So this is example 2. So example 2. I'm going to, let's just do like a trapezoid, and my marker is not working super well, so let's just see. All right, so we have this trapezoid right here, and then here is the trapezoid that it is similar to. Going way out here. Let's move this back on to where we can see it. So this is 15. We'll say this side is 35. We'll name this side as 40. And again, let's go with the shaded one is the original. So this time I'm just going to make this one the shaded one. So that, just so you can see that it's not always the smallest one first. That it really doesn't matter, and it doesn't have to be the first one either. So we're going to say that the original one is the shaded. Okay, so first thing that we need to do in order to find a missing side is to figure out what the scale factor is. So I am going to first find the scale factor. So again, all we need to do is new over original. This is our original. This is our new one. So new over original, and either set works, as we saw in example 1. I'm just going to use the 9 and the 15 because those numbers are smaller. So 9 over 15 would be new over original. I can reduce that by 3, so my scale factor is 3/5. All right, so now that I do that, there's a few things that you can do to answer the question. I'm going to show you the one that works every single time, because I know some of you like the one that is the foolproof method. So I'm going to show you what will work no matter what. And that is, if we now make a proportion using our scale factor with the other fraction being the one that contains the missing side. So we know our scale factor is 3/5. So we know that if we set up any other fraction, it needs to equal 3/5. And if we set up 21 over 35, reduced by 7, that would give us 3/5. So what we need to do is set up the fraction, the scale factor, equal to the fraction of the corresponding sides that we're missing. So new over original would be A over 40. And then again, at this point, you have quite a few options because, for one, you can see that we just multiply by 8. So you can see that the missing side is 24. But again, to show you a method that works every single time, what I'm going to do is I am going to multiply the diagonals together. So 5 times A is going to equal 3 times 40, which basically means that 5A is 120. Divide both sides by 5, and I find that A is 24. So different ways you can figure out what the missing length is. This way will work no matter what. Once you set up the proportion, you didn't have to do this, but this works every time. Another thing that we could do is what I mentioned earlier. If we take our scale factor multiplied to the original, we'll get the new. So if we took our scale factor and multiplied it to the original side, we would get the new side. All right, so for the last example, I want to do a problem where we are solving for x. So I'm going to move this a little bit. I think I can fit this down here, or I'm going to try anyway. So, all right, so last example, example 3. So I think I might just stick with, let's do a triangle. All right, so we have 2 triangles. They are similar. I'm going to tell you that this one is 18 and 24. This one we'll say is 12 and x plus 9. All right, so we're going to do this similar to how we did the last one. So first thing that we need to do is establish what our scale factor is. So the scale factor, let's say this one. So let's say this one is the original one. Okay. So new over original. So 18 over 12, and we can reduce that by 6, so we get 3 over 2. All right. So now what we need to do is take that and set up a proportion, because we know that all of the other sides are going to be in the proportion of 3 over 2. So if we do new over original, so that means we need to set up new over original, just like that. And now to solve, we can do what we did up here. So if we multiply the diagonals together, so if we multiply these together, we'll get 3x plus 27. If we multiply those two together, we get that it equals 48. So now we just need to solve. So subtract 27, so 3x would be 21, divide by 3, so x is 7. And again, multiple ways to figure this question out. This is not the only way to figure this question out. This is the way that will always, always work. All right. Remember, you can replay the video and pause if you need to if I went too quickly.